Ever wondered how Google, a company with hundreds of thousands of employees around the world, manages its software development without chaos? With about 183,000 of employees across Alphabet, including tens of thousands of engineers, Google has to break big problems into small, manageable pieces. It does this by careful design of teams, processes, and culture. Google's engineering organization is hierarchical, yet decentralized. At the top, executives own product portfolios, which are divided into sub-areas and finally into small cross-functional teams. Think of each team as a mini startup, 6 to 10 people with software engineers, a tech lead, product manager, and often a designer. These teams own an entire feature, end-to-end, from design to production. This way, day-to-day decisions can happen within each small team for speed, while alignment across teams is kept through higher-level planning, such as quarterly OKRs. Now, let's look at what each role would do in a specific context. Let's consider implementing AI in Google Search. At the top, we have the CEO. He looks at the big picture and decides that Google needs to stay ahead in search technology. AI becomes a strategic focus, and he communicates the vision clearly. We want smarter, AI-driven query suggestions for users. Next, the SVP of Search and AI receives this direction. He sets goals for the search division, like increasing search relevance and engagement using AI. He approves budgets and resources and works closely with vice presidents to plan execution across multiple teams. Then we have the VP or Director of Search Engineering. They oversee multiple product areas, including our new AI query suggestions. They assign teams to the project, product managers, engineering managers, software engineers, and ensure resources and timelines match the SVP's strategy. Product manager researches user behavior and identifies user pain points. For example, users often type vague queries and don't find results efficiently. PM designs the AI-powered query suggestions feature and creates a roadmap, detailing exactly what the feature should do. They work with software engineers and engineering managers to discuss feasibility and prioritize features. Engineering manager receives the PM's requirements and breaks the work into engineering tasks. They design the technical approach and ensure that deadlines are met, technical blockers are solved, and code quality is maintained. Software engineers then implement the feature based on the EM's guidance. They write code for the AI algorithm, integrate it with backend, update the front-end UI, and test everything. They fix bugs and optimize performance. QA and testing engineers validate the feature for correctness, speed, and user experience. Any bugs are reported back to the software engineers, ensuring the feature works flawlessly before launch. Once the feature is live, site reliability engineers take over. Their job is to keep Google Search stable, fast, and available to billions of users. They monitor system health, set up alerts, and make sure the new AI suggestions don't slow down search results. If traffic spikes or servers fail, they respond quickly and automate fixes to keep everything running. In short, they ensure that AI-powered query suggestions work, not just in testing environments, but also in the real world. Internally, Google famously uses a monolithic code repository, so its entire codebase is stored in one repo in its internal version control system called Piper. Back in 2015, it already had over 2 billion lines of code, and it has only grown since then. Every developer, no matter which team they are on, checks out from the same code tree. That means a software engineer working on Google Cloud, in theory, see or even reference code from YouTube, Search or Maps. This setup makes sharing libraries and collaborating across teams extremely efficient. Instead of reinventing the wheel, engineers can plug in existing solutions. But working with billions of lines of code isn't easy. Google had to build custom infrastructure around Piper, like distributed builds, advanced code search, and automated testing, to make it usable at this scale. On top of this unified repo, Google provides shared platforms and internal services, for example Bigtable for databases, Kubernetes for orchestration, common libraries for authentication, logging and monitoring, and even machine learning frameworks like TensorFlow. Think of this as building blocks. Teams can snap them together to ship features faster, instead of spending time on reinventing infrastructure. At Google, the code review and release process is rigorous and largely automated. When an engineer finishes a change locally, they upload it to Critic for peers to review. Peer review is mandatory. It helps to catch bugs or design issues early. Automated tools run in the background, static analyzers, style checkers, and small test suites that give instant feedback. Once the review is approved, the change is committed to the shared repo. The central build system then builds a full artifact and runs more extensive tests like integration and system tests. If all checks pass, the change enters the release pipeline. Google typically uses progressive rollouts. New code first goes to internal environments, then to small percentage of real users, and finally to everyone. Feature flags are used to toggle new behavior on or off quickly. This way, any issue can be rapidly rolled back or fixed with minimal impact. And once a feature is stable, Google doesn't ship it and move on. It experiments. Telemetry from billions of users feeds into large-scale A/B tests, so every new feature is validated against real-world behavior. Only the versions that improve metrics and user experience survive, while others are refined or retired. With so many services, Google leans heavily on automation and site reliability engineering practices. SRE teams partner with product teams to define reliability targets and measure them. In practice, that means setting strict service level objectives like error rates, latency, or uptime, and monitoring them via metrics, logs, and distributed traces. Dashboards alert on deviations, so when they detect any user impacting symptoms, they instantly notify on-call engineers. Google runs massive automated test suites, unit tests, integration tests, performance tests, often triggered by every minor change. They even do chaos experiments internally to validate that systems can handle failures. Incident response at Google is highly structured. When an outage occurs, an incident commander leads the response, with communications lead for communicating updates and an operations lead fixing the problem. After resolution, teams write detailed blameless postmortems to learn and prevent recurrence. Google runs on data. Team and individual goals are set using objectives and key results, a framework Google helped popularize. Each team writes ambitious objectives and key results that are quantifiable. OKRs are transparent across the company, aligning everyone on top priorities. For example, a product team might have an OKR like increase user engagement by 20%, measured through metrics like daily active users or load times. On the engineering side, Google tracks performance metrics as well. Deployment frequency, code review times, mean time to recovery after incidents, code health scores, and customer impact metrics. These feed into retrospective reviews and future planning. Engineers are incentivized to take ownership and improve reliability. Their performance evaluations reward technical leadership, innovation, and code quality, not just feature delivery. Clear career ladders, from junior engineer up through senior staff and distinguished engineer levels, set expectations for contribution and mentorship. With teams spread globally, communication is critical. Google provides rich collaboration tools, Google Chat and Groups for real-time chat and email lists, Google Docs and internal wikis for documentation, and even an internal Q&A platform similar to Stack Overflow where engineers can share answers. New engineers called newglers are paired with an experienced mentor outside their team to help them ramp up. Teams hold regular tech talks and lunch and learns to demo new systems or share research. Google also hosts company-wide meetings and internal conferences where engineers present projects. There is an explicit culture of always be learning, so asking questions is encouraged. Many Google services communicate via APIs or gRPCs, so teams can work independently. Platform teams provide shared abstractions. For instance, a cloud storage team offers a single interface that all products use, and an internal identity team provides authentication. This decoupling lets teams move fast without stepping on each other's code. Inside Google, major platform initiatives like Kubernetes for container orchestration or Android as a mobile platform are treated as internal products with their own dedicated teams. This platform as a product mindset means development is layered. Low-level teams build and support infrastructure, while higher-level product teams build on top of it. That way, core complexity is contained, and product teams can innovate by consuming those services. Google invests heavily in developer experience. For example, Bazel provides extremely fast builds by parallelizing work across Google's data centers. Engineers have advanced code search tools, so they can instantly find how functions are used anywhere in the repo. Linting and style tools automatically reformat code. Bots update dependencies to the latest versions. Google even uses AI assistants that can suggest code snippets or find examples from Google's gigantic codebase. These tools dramatically reduce friction. A developer can scaffold a new service with templates, get real-time feedback on errors, run local emulations of cloud services, and ship code with one command. Shorter feedback loops means faster iteration and higher satisfaction. Google recruits at scale with dedicated teams. Technical interviews focus on problem solving and system design. They filter for Googliness, so for collaboration and learning mindset. Once hired, clear career paths guide growth. Engineers advance through levels by demonstrating impact and taking on more responsibility. Internal transfer and mobility are common. Engineers can switch teams or roles fairly easy, bringing new ideas where needed. Mentoring programs and in-house training like Googler to Googler classes helps skills spread. Underpinning it all is a distinctive culture that prizes ambitious thinking, psychological safety, and customer focus. Leaders set an example by being transparent, encouraging open discussion, and rewarding learning. In summary, Google scales its engineering complexity through design of teams, platforms, processes, and culture. Tiny autonomous teams works on well-defined slices of Google's massive product suite, all plugging into centralized tools. Code is reviewed and tested at every step. Rollouts are staged with feature flags, and SREs ensure reliability through metrics and blameless postmortems. Goals are measured via OKRs, and engineers live a culture of learning and ownership. Running thousands of developers in parallel isn't magic. It's systematic engineering of the engineering process. With the right structure, platforms, automation, and culture, Google and any other large tech organization can move fast at enormous scale. If you enjoyed this video, hit like, subscribe, and tap the bell for more tech deep dives. See you in the next one.